All right, so we have Science Steve. He's ice skating with a velocity of 2 meters per second. He has a mass of 70 kilograms. He skids to a stop in about 4 seconds. We want to know how much net force is necessary to stop him in this certain amount of time, right? So we have an object in motion which changes its motion, right? It experiences an impulse, which means that there has to be a force acting on it to do that, right? So I've gone ahead and I've drawn my before and after diagram, and then again, we're going to start using this during diagram to represent the forces during this interaction. So I've got its starting mass, its velocity. We also have its final mass and final velocity, right? Skids to a stop. So if you're traveling in this direction and you come to a stop, that means that something has to be interacting with you in the opposite direction, right? That force has to be going against motion. Okay, so on my force vector diagram, I'm just going to show the net force going in the opposite direction of Steve here. Okay, so the first thing we want to know is how much net force is necessary to actually stop him. Recall that to calculate net force, the tools that we have so far, we know that the net force is equal to our change in momentum over our change in time. Okay, well, we have our change in time. It said it took him 4 seconds to make that change. But we are missing the change in momentum from our toolbox. Okay, so to figure out the change in momentum, we just have to figure out what was his initial momentum before, what was his initial momentum afterwards. Okay, so recall that momentum is equal to your mass times velocity. So we have the mass and velocity both before and after. And if we can figure out the momentum before and after, we can figure out the change in momentum. Okay, so our initial momentum is equal to 70 times 2, right? Mass times velocity. So that should give us 140 kilogram meters per second. And if we compare that to the final momentum, okay, the mass times velocity, well, 70 times 0, right? He's not moving. So we can assume that his final velocity is 0. I'm sorry, his final momentum is 0 because his velocity is 0. Okay, so this is a pretty easy change to calculate, right? What's the difference between 140 and 0? Okay, so the net change is 140 kilogram meters per second in the opposite direction. Okay, so now that we have our change in momentum and we have our change in time, we can calculate the net force, right? So net force is equal to change in momentum over change in time. So this equals the change in momentum, which is 140 kilogram meters per second. And that's going to be over the change in time, which was 4 seconds. Okay. So 140 over 4 gets us 35. Okay, so that is going to be the net force, 35, and since it's force, it's going to be in newtons. Okay, and I've only included this negative direction here to show that there was a negative change momentum. But if I just want to figure out what was the net force, I can either specify it with a positive or negative, or I can just specify it with a direction. Okay, so we know that we have a net force 35 newtons, okay, and that's going to be in the left direction. Okay, and there you go.